In this video, let's learn about quadrilaterals. The rectangle. The rectangle is a parallelogram with 4 right angles. It has 4 right angles. Diagonals are congruent. And then it also has all the properties of a parallelogram. Let's take a look at a few examples. Example 1, it says find the measure of angle 1. All right, so the measure of angle 1 is right here. We know that this is a rectangle, and so this is going to be a right angle, which is a 90 degree. That means that angle 1 measures 70, because 70 and 20 add up to 90. All right, we also know that rectangles have all the properties of a parallelogram. So I know that AB is parallel to DC. If this is my transversal, then I know that this 20 degree is congruent to angle 2 because alternate interior angles are congruent. So this guy is 20 degrees. Okay, so then the other thing I know is that the diagonals are congruent and they bisect each other. So these two pieces are congruent. And what we've got here on the left is I'm going to highlight this guy, an isosceles triangle. If these are the two congruent legs, then I'm going to have two congruent base angles. So this angle is also going to be 70 degrees. So if I'm looking at this triangle that I've kind of outlined in gray, and it has two angles that are 70, well, the sum of those two is 140, and I'm able to solve for angle 3. 70 plus 70 is 140, and the 3 angles in a triangle add to 180, so 180 minus 140, angle 3 is 40 degrees. In example 2, we want to find out what BC is. All right, so let's see. Well, I'm given that AD is 10. In a rectangle, these sides are congruent. So 10 is equal to BC. Now I want to find out what DB is. Okay, so diagonals are congruent and they bisect each other. So if this segment here is 8, then this segment here is also 8. And since this is a diagonal and it's congruent with this diagonal, and the sum of those two is 16, well, this diagonal is 16, or 8 and 8. So if I'm trying to find out what DB is, well, that's just going to be 16. It's the whole length. And then lastly, I want to find DC. I think we're just going to have to use our good old-fashioned Pythagorean theorem. So let's take a look at this triangle here. I've highlighted in green. I've got the short leg is 10. I've got the hypotenuse is 16. This is what I'm trying to solve, so I'll just identify that as an x. So 10 squared plus x squared is equal to 16 squared. X squared is 16 squared minus 100, and I'm going to take that to Desmos. (16 squared minus 100), and don't forget we have to square root that. And so if I square root, that's about 12.5. I'm going to say approximately 12.5. In example 3, we know that AE is 5x minus 15, and DE is 2x plus 6. Okay, in a rectangle, these are congruent, so I can set 5x minus 15 equal to 2x plus 6. Let's do a little bit of algebra. If I subtract 2x on both sides and add 15 to both sides, I have 3x is equal to 21. Dividing gives me 7. So if I want to find out what AC is, let's plug 7 in for the x. So 5 times 7 minus 15. Well, that's 35 minus 15, which is 20. So this piece is 20. So since we know it's been bisected, this section over here is also 20. So the whole length is 40. 20 plus 20 makes the 40. All right, so now let's find DC. Okay, so we know that x, well, we know that, I'm going to erase this little bit here. We know that this guy is 20 also, because these are congruent. And if I want to find out what DC is, let's see. Whoa. I got 20, I got a 40 on the diagonal. I'm going to need a little bit more help. Okay, so I know that this is 3x plus 3. I forgot to put this on my triangle. Okay, so 3x plus 3. Let's plug in the 7. So that's 3 times 7 plus 3. 21 plus 3 is what, 24? All right, now we're back in business. Let's take a look at this big triangle here. I'm going to highlight in red. All right, we're going to do, since it's a right triangle, Pythagorean theorem again. My hypotenuse is 40. My short leg is 24, and my x is going to be down here. So it's going to be x squared plus 24 squared is equal to 40 squared. And if I subtract 24 squared, x squared is equal to 40 squared minus 24 squared. And that's what I'm going to take to Desmos. Okay, so I have, let's clean up a little bit, 40 squared minus 24 squared is 1024, and now I want to take the square root of that, and that equals 32. So that the base of this triangle is 32. Last example, ABE is 27. This time I'm going to write down everything. ABE is 27. DB is 17. So this piece right here from D to B is 17 all the way. And then BC is 8. We want to find the measure of DAB. So DAB, well, the measure of DAB, since this is a rectangle, is 90 degrees. So that wasn't too bad. Measure of DBC. Now I want to find this angle here. From D to B to C. That's what this is asking here. From D to B to C. Well, if this is a right angle, these guys are complementary. That means that they add up to 90. So I just need to subtract 27 from 90. Let's see, what is that? How about 63? And then the last one, DC. Okay, so this is going to give me another right triangle right here. This time, again, I'm finding the base of this. My hypotenuse is 17, so it's going to be x squared plus 8 squared is equal to 17 squared. If I subtract 8 squared, I have 17 squared minus 8 squared. Let's take that to Desmos. And of course, I want to take the square root, and that's 15. So x is equal to 15, and that is what DC is.